Algebra 2, Lesson 19. Part A is called Value Word Problems. I really enjoy these. I hope you guys do too. Often they're about coins, but not always. You'll see an example of a coin and something else here. So value word problems, like it says, include at least one statement about the value of items. Please remember that to find the total number of a group of one particular item, we multiply the value of one of those items by the quantity of the item, so like how many there are. For example, to find the value of 31 nickels, we know that nickels are 5 cents each. So you take 5 times 31. When you do that, you get 155, and that tells you the number of cents. And if you need to know dollars, then you would divide by 100 because there are 100 cents in $1. So that'd be that. And I wrote it without a dollar symbol just to be consistent. But so we're going to do that sort of thing to solve these problems. It is possible to guess and check these. One really nice thing you like about these, when you're talking about the number of things, you're almost always going to be getting whole numbers. You're not going to have part of a nickel, and the next one's going to be about fish, and yes, you can have part of a fish, but you won't for these. So I think you'll like that. Anyway, let's look at example 1. This person had 50 nickels and dimes total. So it's not saying had 50 nickels and some dimes. It's a total of 50 nickels and dimes, whose total value was $4. All right, and then we're supposed to find out how many of each type of coin. All right, so to do this, we're going to write 2 equations based on this. There's always one equation about how many things there are, and then another one about their value. All right, every time. So equation, let me just write that over here as a label, but I would like to box this so that you have it to look back at easily. So we have an equation about how many there are. I'm just going to put a number sign. And then another equation about their value. Okay? So, how many there are? Well, there are 50 total coins. It'd be the number of nickels plus the number of dimes equals 50. There's one about the number of items. And then the other one is about their value. Well, okay, so we can do this all in terms of dollars or all in terms of cents. If you do this in terms of dollars, you need to use decimals. I like to avoid that. But if we did it in terms of dollars, I'm going to write that on the side. Each nickel is 5 cents. That's 5/100th of a dollar. So 5 cents times the number of nickels. Each dime would be like that. And that would equal 4 because it's a total of $4. So the value of all the nickels plus the value of all the dimes equals the total value, which is exactly $4. All right. So what I like to do to avoid having decimals is to write these in terms of cents. If I multiply each term times 100, see, 5 times the number of nickels, 10 times the number of dimes, but then that's 400 cents instead of $4. Okay, so my automatic thing is to write these in cents. 5 times the number of nickels plus 10 times the number of dimes, and then just convert those dollars to cents, so 400. And then, look, this is all set up to do substitution or elimination. You get to choose. I tend to prefer elimination. For these types of problems, it's totally up to you. I think for notes, I'm going to go ahead and just do elimination. I would like to, it's really easy to multiply by powers of 10. So I'm going to take negative 10 times everything in my first equation. Okay, I'll just show you there what I'm doing. I'm going to write it underneath here. So I have negative 10 times the number of nickels minus 10 times the number of dimes equals negative 500. I did that so the number of dimes will cancel. I could have gotten rid of nickels instead, but it's always easy to multiply by powers of 10. So those cancel. Here I have negative 5 times the number of nickels equals negative 100. Divide both sides by negative 5. It's always by the coefficient of your variable. Negative divided by a negative is positive, which is good. I won't get negative answers, and I won't get fractions or decimals for these. 100 divided by 5 is 20. There are 20 nickels. And then there are a total of 50 coins, so the number of dimes has to be 30. 50 minus 20. And that's it. To check word problems, go back to the words, not your original equations. Okay, I have a total of 50 coins. Let's make sure that they're worth $4. So 20 times 5 is 100, 30 times 10 is 300. That is 400 cents, which is $4, so then I know it's right. Okay, so that's it for that coin problem. I think they're fun. Again, I really hope you guys do too. This next one is about fish. But still talking about their value. Someone's buying fish at a market. So, the fishmonger sold codfish for 6 pence each and mussels for 1 pence each. If Harriet bought a total of 26 items and spent 86 pence, how many codfish did she buy? Well, we're not generally as familiar with these as we are with dollars and cents, but it's still the same type of problem. We have one for how many cod and mussels she bought. Okay, 26 items. So I'll put the number of cod plus the number of mussels is 26. And then I have another equation for their value. Okay, it's 6 for each cod. So 6 times the number of cod plus 1 times the number of mussels, and I don't have to put the 1, equals the total that she spent, which is 86 pence. All right, and now this one's just begging for elimination because those. I'm just going to take negative 1 times everything in one of the equations. I chose the first one so that I don't have to divide by a negative this time. All right, those cancel. 6 minus 1 is 5, so 5 times the number of cod equals 86 minus 26 will be 60. Divide by the coefficient of your variable. So the number of cod is 12. We could find the number of mussels, but they only asked how many codfish did she buy. That. Done. All right. Oh, to check it, I would go ahead and find out how many mussels she bought and just make sure that that the value works out, just like with the coins. But let's move it on to part B, which is about triangles again. Okay, so remember, something about the measures of angles, and I bet it's in triangles. The sum of the measures of the angles in any triangle is 180 degrees. All right. When you know that two angles in one triangle are congruent to two angles in another triangle, see, one tick, those two are congruent, two tick, those two are congruent. By the way, as I learned on that one bell work that this wasn't in your notes before, apparently, that was pi. Why did I write pi? That was silly. I know why I did that. The top of my lowercase pi is the same as the top of a congruent symbol. Okay, so that's congruent. Okay, so whenever two angles in one triangle are congruent to two angles in another triangle, the third angles have to be congruent, because all three of these add up to 180, and all three of these add up to 180. They have to be the same. right? There's some room here to kind of prove this algebraically. So I guess let's go ahead and do that. Let's see. So we have, from the drawing, we know that the measure of angle A is equal to the measure of angle D, and the measure of angle B is equal to the measure of angle E. That's what those tick marks are telling us, right? And this triangle says A plus B plus C equals 180, because it's the three angles in the triangle. They have to add up to 180, right? But if A is the same as D, I could put a D here. And if B is the same as E, I can put an E here, right? Okay, what did that do? Well, on this triangle, we know that D plus E plus F equals 180, because again, any triangle. Okay, so this equals 180, and this equals 180. Then I can do substitution. D plus E plus C has to equal D plus E plus F. Subtract D from both sides, subtract E from both sides, C equals F. Which you kind of should have known that already intuitively, but we'll just kind of prove it algebraically. Anyway, so if you know two angles are congruent, the other ones have to be. That's what AA means. AAA is signifying. Okay, angle, angle. If you know two of them are congruent, the other one has to be also. So that's that. We use that fact to solve some of these similar triangle problems that you were doing already, only now they're not going to give you all three angles. But we know two of them, and that's enough to know that the triangles are similar. So that's the only new thing, is they're telling you fewer angles. You still do scale factor and figure it out. Now, one thing I recommend, those angles aren't situated the same way. I like to redraw the triangles so they're turned the same way. So it's a lot easier to tell which are the angles that are congruent to each other, so you know which sides are proportional. So I'm going to turn this one so that one tick is up here, and I want them situated the same way. So I'm going to put the one tick there and the two tick here. Between the one and the two ticks on this triangle is a 5. The other one that's next to the two tick angle is 4. And then here's 7. Over here, between the one tick mark and the two tick is X. And then the other one that's next to the two tick angle is 6. And then the other one's a Y. Now my corresponding sides are all like in the same position, and it's much easier to get my, see what corresponds. So I take the 4 and the 6, okay, the sides where they're both numbers, use those to find the scale factor. 4 times the scale factor equals 6. Divide by 4, so the scale factor that reduces is 3/2. So I just take 3/2 times 5, and that gives me X. 5 times 3/2, 15/2. That equals X over there. I'll get ready to circle these. And then Y is, okay, so 7 times 3/2. And that's all you do for those. And that's all we're doing for the notes. Have fun.